There is more to conditional probability than just sampling without replacement. We now need to look to the conditional probability formula and tackle more difficult problems. I encourage you to shrink the sample space and avoid the formula when possible, because I believe a person develops a better feel for probability that way. But there are problems that require the formula, and we strengthen our understanding by being able to grasp its meaning. Notice we should divide by the probability of the given event. This is because of all the possibilities we began with in the sample space, only those tied to the occurrence of the given event are still possible. I like what the study of outcomes of 2 dice can do for our understanding. Because there are 6 sides per die and 2 dice are rolled, there are 36 distinct outcomes. If asked to find the probability that the sum is 4, we simply consider the combinations of 2 dice that yield a sum of 4. This is 3-1, 1-3, and 2-2. To understand why 2-2 only counts as one distinct outcome, look at this lattice diagram which displays the combinations of one blue die and a second die that's red. A 2 on the blue and a 2 on the red is the same distinct outcome as a 2 on the red and a 2 on the blue. No matter how we orient them on a surface, there is only one distinct outcome. Not so for the 1 and 3 combinations. Getting 1 on red and 3 on blue is distinctly different from getting 1 on blue and 3 on red. Here's a good problem. If 2 dice are rolled and the sum is 4, what is the probability that at least 1 2 is rolled? Easiest way? Shrink the sample space from the 36 combinations down to what was given, that the sum was 4. This gives just 3 possibilities, and of these 3, only one involves rolling at least 1 2. Hence our probability is 1/3. Only one of the 3 sums of 4 involves at least 1 2 being rolled. Using the conditional probability formula, we get the same thing. The numerator is the intersection of rolling a sum of 4 and getting at least 1 2. Of all 36 pairs, only one meets this requirement, the 2 and the 2. Thus, 1/36 is the probability of the intersection. The denominator is the probability of the given event, namely that a sum of 4 must be rolled. There are only 3 of 36 combinations of dice that qualify. Therefore, the conditional probability is 1/3 divided by 3/36. This reduces to 1/3, just like when we shrunk the sample space. But be careful using the formula once you are proficient at shrinking the sample space. The formula itself considers the entire sample space to be available for purposes of getting both the numerator's probability and the denominator's. When using the formula, we must maintain the original sample space of 36 outcomes in the numerator and denominator. In other words, either use the shrinking the sample space approach or use the formula. Don't shrink the sample space if putting probabilities into the formula. Now, find the probability that the sum of 2 dice is 8, knowing that at least 1 5 is rolled. Formula approach, the probability of the sum is 8 and at least 1 5 is rolled. Well, this is 2 out of 36. Divide this by the probability that at least 1 5 was rolled, because this was the information given, the condition given. There are 11 of 36 combinations whose sum is 8. Thus, 11/36. Divide 2/36 by 11/36. Hopefully we see that this is 2/11ths. And this is exactly what we get if we instead applied the shrinking sample space approach. Knowing that at least 1 5 is rolled, we would shrink from 36 possible outcomes down to 11, and 2 of these involve rolling at least 1 5. 2/11ths is our answer.